Okay, so finishing up the practice questions from the second experimental design for a redox table sheet. We were on number 3. We had done the first equation, first reaction, so we had bromine gas or bromine liquid above the silver, and we were on the second one, saying that silver would be going, silver metal would be going to silver ion by losing an electron, and if it's losing an electron, it means it's being oxidized, and if it's being oxidized, it means it's the reducing agent. Whereas iodine, another diatomic atom, would be going to iodine with a -1, so it would be gaining an electron, which means it's being reduced, which means it's the oxidizing agent. Because it's not spontaneous, no evidence of reaction, it means that the reducing agent has to be above the oxidizing agent, which means the I2 is going to go below the silver. So over here, this will be I2 liquid plus, again, 2 electrons because of the diatomic, it has to balance, 2I negative. Okay? Next one, it says no redox reaction, meaning that there's if it's still not spontaneous, right? Because there's no redox reaction here. So if it was going to be a redox reaction, if we look here, this is still going to be +2 and -1. If there was really a transfer of electrons, this would be going to Cu solid and I2, right? And so copper would be gaining electrons, which means it's being reduced, which means it would be the oxidizing agent if that reaction happened. Whereas the I would be losing electrons, going from negative to 0, which means it's being losing electrons, being oxidized, which means it's the reducing agent. And yes, I do Leo and Gur in my head all the time. Because there's not a redox reaction, we would say the redox reaction is not spontaneous, which means the reducing agent has to go above the oxidizing agent, or the oxidizing agent below the reducing agent, since the reducing agent's already here. So Cu has to go below here. Say Cu2 positive aqueous plus 2 electrons would go to Cu solid. All right, and then bromide and chlorine, and if it was a reaction, it would be going to 2Br negative and Cl2 gas. Okay, so the Br would be going from 0 to negative, which means it's gaining electrons, which means it's being reduced, which means it's the oxidizing agent. Whereas the Cl is going from negative to 0, which means it's losing electrons, which means it's being oxidized, which means it is the reducing agent. Okay? It's not spontaneous, means the reducing agent has to be above the oxidizing agent. So the Cl needs to go above the Br, which would be here. And remember, the Cl negative is the reducing agent. It goes on this side, 2Cl negative. Now, this is probably the one, like I said earlier, that screwed you up. And it's because of the fact that 3 of these are forming ions by becoming negative. Usually we have our ions over here and our pure substances over here, because usually the ions are positive. But when the ions are negative, they can't be on the left-hand side, because you have to add your electrons on the left-hand side. And if you add electrons to negatives, they're just going to get more negative, right? So for Cl, Br, I would be true for fluorine. Those ones form their ions by becoming negative, right? So it'll be the diatomic atom for them will be over here, and the ion will be on the reducing agent side. All right, so here's our SOA. And here's our SRA going up. All right, one more. Hopefully these are getting better. Now, if you got stuck on these and didn't get to number 4, turn the video off, try number 4, and then turn it back on to check it, because they should be getting easier now. All right, so SR solid going to SR2 positive means it's losing electrons, which means it's being oxidized, which means it's the reducing agent. Whereas Ce3 positive is going to Ce pure, which is 0, so it's gaining electrons, which means it's being, shoot, did I just screw that up? It's gaining electrons, which means it's being reduced, which means it's the oxidizing agent. Just for a second, I thought I said oxidizing, where I should have said reducing. All right, it is spontaneous. Therefore, the OA is above the RA. So over here on the side, and again, make sure you leave enough space on the top and the bottom so you can get other things in. So we're going to have Ce3 positive aqueous plus 3, the paper moved, 3 electrons going to Ce solid. Notice I dropped the 2's, right? You wouldn't put 2 here, 6 here, and 2 here, right? Chemistry teachers would start to twitch. You need to write it as the most reduced, whole numbers but most reduced. All right, next one. There's my Ce again, but this time it's Ce3 positive. It's no evidence of reaction, but if it was reacting, it would be going to Ce solid, and nickel would be the one becoming the ion, and we know that nickel goes to 2 positive. Okay, so 3 positive going to 0, it's gaining electrons. If it's gaining electrons, it's being reduced, so it means it's the oxidizing agent. Nickel's going from pure nickel to an ion, which means it's being oxidized, which means it's the reducing agent. No evidence of reaction means the reducing agent is above the oxidizing agent. Oh, I forgot to write the other half action in over here. Sorry, I totally lost SR. So SR pure was the, and it was underneath, yeah. SR pure was the reducing agent, so it goes there. And then the SR2 positive aqueous plus 2 electrons goes down here. All right, now we're ready. So nickel goes above the Ce. And again, it's the reducing agent, so it goes here, nickel solid. Whereas Ni2 positive plus 2 electrons would go here. And that, of course, is an aqueous. All right, next up, nickel solid going to nickel 2 positive. Just like above, it's going to be the reducing agent. Whereas we have H positive going to hydrogen gas, so it must be gaining an electron, which means it's being reduced, which means it's the oxidizing agent. This is spontaneous, which means the oxidizing has to be above the reducing, so the hydrogen goes above nickel in the chart. So 2H positive aqueous plus 2 electrons going to H2 gas. All right, last one. PT going to 2H positive. So obviously this is going to be hydrogen gas over here. And PT, if you look at it in the periodic table, it'll show you that its most common ion is PT4 positive, aqueous. Okay, so PT is definitely losing electrons, which means it's being oxidized, which means it's the reducing agent. Whereas hydrogen is gaining electrons, which means it's being reduced, which means it's the oxidizing agent. Again, it's non-spontaneous, so reducing goes above the oxidizing, so the PT has to go on top here. So it would be PT4 positive aqueous plus 4 electrons going to PT solid. And you are done. This will be the strongest oxidizing agent up here. This will be the strongest reducing agent down here going up. Okay, so hopefully these ones are pretty good now.